If I ask you what is trigonometry, you will promptly answer, it's very easy. Trigonometry gives us some functions. Using those functions, we can measure any angle of a triangle by its three sides. Yes, you are correct. But if I ask you, how does trigonometry generates this function? Then you may be a little confused. In this video, I am going to clear all your confusion about trigonometry. Trigonometry establishes relation between an angle to its sides and sides to its angle using some basic functions. So, ka, toa. So, ka, toa are the three basic functions of trigonometry by which it establishes angle-side relations and also use these functions to measure either the magnitude of any angle or the length of any sides of a triangle. Let me explain in detail. ABC is a right angle triangle. The side opposite to the right angle is the hypotenuse. We know that all the sides of a right angle triangle are related to one another. The Pythagorean theorem AB squared equals to AC square plus BC square proves this relation. Now leaving the right angle, there are two more other angles, angle A and angle B. We can establish angle-side relation using trigonometry. Let's consider angle A. Angle A has initiated from the side AC. So, AC is its adjacent and BC is its opposite. Now observe, if we change the length of the opposite, how the magnitude of the angle gets changed. But I suggest you to watch this video on angles to get a clear concept of angles and its units. Now, if we decrease the length of the opposite, the length of the hypotenuse will also decrease. Have a look into the Pythagorean theorem. If the value of BC decrease, then it will decrease the value of AB. As a result, the side of the angle will also decrease. And when both the opposite and hypotenuse increase in length, the side of the angle will also increase. So, the angle A can be represented by opposite and hypotenuse. Trigonometry says this relation as sine function. Sine function determines the size of an angle by its opposite and hypotenuse. So, sine of theta or sine of angle A equals to opposite upon hypotenuse. But it is a function. When we put the actual length of the opposite and hypotenuse in this function, it will give us a ratio. So, to get the sine ratio for angle A, let's assume the length of the opposite is x unit and the hypotenuse is 2x unit. So, the sine ratio of angle A equals to x upon 2x, or it is half, only half, because it is a ratio, it has no unit. Any angle, the sine ratio of any angle is half when the angle is 30 degree. And to convert the angle value in radian, we have to simply multiply 30 degree by pi by 180 degree. So, when 30 degree will be multiplied by pi by 180 degree, then we will get pi by 6 or 0.523 radian. This way, the trigonometric function establishes angle-side relation. Again, if the length of the adjacent and hypotenuse change, the side of the angle A will also change. Observe, if the adjacent increase in length, then the hypotenuse will also increase and the angle size decrease this time. And when the side of the sides decrease, the angle size increase. So, we can represent angle A as adjacent upon hypotenuse or A upon H. Trigonometry says this relation as cos of theta or cos function. So, cos of angle A equals to adjacent upon hypotenuse. Now, let's assume the adjacent is of x unit and the hypotenuse is of 2x unit. So, cos of angle A or cos of theta equals to x upon 2x, or it is half, and we know that cos theta is half at 60 degree. Same way, we can also represent angle A by the opposite and adjacent by the TOA function. Yes, TOA means tan of theta. Tan of theta equals to opposite upon adjacent. Let's assume the adjacent AC and opposite BC both are of equal size. AC and BC both are x units. Therefore, tan of theta or tan of angle A equals to x upon x, that is 1 upon 1, or it is 1. Observe, trig functions give us ratios, and a ratio is always unitless. Therefore, tan of angle A is 1. It has no unit. And we know that tan theta is 1 at 45 degree. Now to get the magnitude of angle A in radian, we have to simply multiply 45 degree by pi by 180 degree. So when 45 degree will be multiplied by pi by 180 degree, we get pi by 4. Substituting the pi value, that is 3.14, and when dividing by 4, we get the angle value in radian, that is 0.785 radian. So tan function represents any angle by its opposite upon adjacent, and when we put the actual value of the opposite and adjacent in the tan function, we get the tan ratio, and from the tan ratio we can get the size or the magnitude of any angle either in degree or in radian. Same way, we can also establish the trig ratios for angle B. For angle B, AC is the opposite and BC is its adjacent. If we decrease the length of the opposite, the length of the hypotenuse will also decrease. As a result, the side of angle B is decreased. So we can say the side of angle B depends on the length of its opposite and hypotenuse. If there is any change in the length of these two, angle B will also suffer a change. The sine function of angle B equals to opposite upon hypotenuse. So the sine ratio for angle B equals to AC upon AB. And when we represent angle B with respect to adjacent and hypotenuse, then it is cos of B or cos B. So cos B equals to BC upon AB. And tan B represents angle B with respect to adjacent and opposite. So I hope you understand how trig functions make angle side relations, which also help to measure them. But all these fundamental functions have their reverse. So represent the sine function. Reverse of sine is cosecant or cosec. Function hypotenuse upon opposite. Ka represent the cosine function. Reverse of cosine is secant or sec. Function hypotenuse upon adjacent. Toa represent the tangent function. Reverse of tangent is cotangent or cot. Function adjacent upon opposite. In my next video, I am going to discuss different trig formulas and their application. So keep watching.